Good morning. Thank you for joining us today. On behalf of AD, I'm Steve Warrants, and we're excited to share with our members how they can increase accuracy, reduce downtime, and increase workplace safety by eliminating boom, arm, and bucket drift. I'm joined today by our member friends at HKX, and I'm going to introduce Branko Horvat, who will take you through the presentation.
Hey, thank you, Steve, and I want to thank all the attendees for joining our webinar today. We want to thank AD for hosting this webinar and helping us organize this event. Our topic today is HKX's engineered kit for electronic load hold and hose burst systems. Our webinar will be primarily focused on excavators, but the solution we're going to show here can or could be applied on other machine types, such as wheel loaders. So let's begin. My name is Branko Horvat. I'm the general manager here at HKX. I've worked in the off-road mobile construction marketplace for over 25 years. My experience is on many different types of construction machines, agricultural machines, marine, and some industrial applications. My main background is in hydraulics and hydraulic control systems, with some background in programming, electrics, and machine mechanics. Joining me in support of this presentation is Robert Burnett, our Director of Inside Sales, and Darren Magner, who's the Director of Outside Sales. Robert and Darren collaborate on making sure that you, the customer, get the solutions and support that you need. Unfortunately, Jay Clicker will not be joining us today to a project we are involved with down in Cape Canaveral. More to come on that project in the future. It's a big win for us, helping drive the future of space flight down in the Cape. As a team, we will address any questions as instructed at the end of this presentation. These are the topics of today's webinar. We'll start with a brief introduction about HKX for those who are not familiar with us as a company. We'll then define the problem statement we are trying to solve with the solution we will present later in the presentation. We'll then provide an overview of the solution and combine that with some success stories. We'll end the webinar by entertaining any questions from you, the participants. As with all presentations, we want to start with some expectations. We want you to walk away from this presentation with a solution that has shown that you can help or tailor your machine to meet several needs when it comes to the machine work. We want you to feel there's a solution on the market that allows for better mobility of moving large attachments and or moving irregular loads. We want you to feel that the road to adopt this technology is easy and that you can install this product yourself. Safety is paramount, and we want you to feel that we have a solution that mitigates that risk. Finally, we want you to feel that our system allows for better control of the machine while reducing costs that come from the machine behavior that can be seen negative from the excavator operator's viewpoint. We also want you to walk away with a positive view that acquiring this kit and installing this on your excavator will bring you value to you and your customers. Before we start, I want to recognize our partners in this solution. Like most projects, it requires a team to be successful. Even though HKX is bringing this to the market, we have a lot of people in the background that have helped us be successful. First, I want to thank our dealers, such as Hawthorne Cat and Tractor Equipment, since they're our direct customers. We want to thank their customers, Alliance and Russo, for allowing us to fit up their machines with our solution and trusting us in applying that solution. Rounding out the list, we acknowledge Hydropower Systems down in Portland, Oregon, and Hydroforce, who is part of the Rexroth group now, for their technology and support. Finally, I would like to thank Komatsu and Wordrock Drills for their teamwork, collaboration to understand machine usage and functionality. So HKX, our history started as a spin-off from man, bucket, and thumb manufacturers. So as you can imagine, we saw a need in the market for functional hydraulic kits to extend hydraulics systems on machines. Our mandate as a company is to build high-quality kits to extend hydraulic functionality to excavators, wheel loaders, and other machines. We have three distinct core competencies: engineering, operations, and customer support. Our engineering is rooted in application and vehicle knowledge, coupled with innovation, fluid conveyance expertise, mechatronics knowledge, and a 360 expert technical support structure and technical publications. We are there from beginning to end of any project or kit you purchase from us. Our goal is to engineer the product as if it came from the factory with additional functionality. The foundation of our operations is our people. Our people provide best-in-class lead time, typically 2 weeks or better on existing kits. We pre-assemble components to simplify installation. We provide bent tubing through our CNC machine. Our product is finally delivered in an engineered packaging to reduce weight and disposal of packaging. Finally, it is our customer support that allows our clients peace of mind when it comes to commercial or technical questions. The HKX mission is simple. We provide extension of hydraulic systems for off-road mobile machines, starting with excavators. We analyze and design kits that outweigh the costs of buying individual components. At the end of the day, we constantly evaluate and improve our business to provide value-added systems to our clients. To define a solution, we need to start with the problem statement. What are we trying to solve here? Today's machines are multi-use in nature. One day you are digging with an excavator, and the next day you want to attach a drill or place pipe or concrete structures near construction workers. As these machines become more application diverse, we need to consider how to make them more adaptable for the type of work they conduct. It is important to be accurate and controllable from one type of work to another. Load-hold valves typically have helped single-use cases on machines. For example, to lay pipe, a load-hold system is used to stabilize the pipe. However, if you want to dig with the machine, you will find that the machine is not as smooth as it was without the load-hold system. Operation is delayed because of the load-hold valves opening and closing. Then take a drill. You may need several load-hold valves beyond the boom, which could include the arm and bucket. Multiple load-hold valves on an excavator causes that machine to become even more specialized, which does not allow the machine to be used for other functions, such as going back to digging. Again, we want to think about the applications where you need to hold a load or hold a position with combined safety. As the diversity of work increases for these machines, we need to consider the quality and reliability of operation. If the machine is not equipped properly, you end up with poor or damaged equipment, as is shown in the picture of the drill above, shown with the red arrow. This poor or damaged equipment leads to downtime in equipment service, which is a cost to you, the customer. Providing a solution to allow the machine to be more stable or increase precise and consistent operation of the machine, which leads to better quality and reliability. Looking at the bottom picture, typical mechanical load-hold systems do not allow you to modify its characteristics on the fly for changing work characteristics once installed on an excavator. How do you provide a load-hold system that allows mode changes so the machine functions properly for the type of work at task? One day you're laying pipe, the next day you are digging, and then the next day you attach a drill. Our solution addresses the ease of making these changes versus alternatives on the market. As with all construction, worksite safety is number one. A lot of solutions in the market do not take into account what happens when there's a burst hose or a major leak in the system. If the operator observes the boom drifting down, their reaction is to move the joystick to neutral to stop the movement. Their first observation should be that the boom stopped its movement. What solutions on the market provide load hold, but also hose burst, where the operator is in control of the machine? Our solution addresses that problem. Existing solutions on the market. First, start with OEM main control valves, pictured in the lower left. Typically, when you hear about a load hold on these valves, this is a simple check valve to prevent leakage across the valve spool. It still has some leakage, but is meant to diminish the leakage caused by the clearance between the valve spool and its housing. Also, the check valve is at the main control valve in an excavator. Between the main control valve and the cylinder, there is no low hold system. On the right, separate mechanical valves mounted directly to the cylinder are sometimes used. These valves are mechanical in nature, which means they rely on internal design, orificing, and/or pilot signals from the machine. These are depicted in the pictures in the lower right. Most of the adjusting for these valves are mechanical and in some cases can only be adjusted by the factory. A little bit more about mechanical load hold valves. When we first think, it's important to understand how these valves work on a machine. What I'm showing is a very simple load hold valve. There are many variations of this type of valve on the market where the manufacturer uses clever ways to create pilot circuits, orificing, and other methods to allow the valve to be smooth and operationally consistent throughout its function. A typical valve is designed to have what we call a fixed ratio. This ratio allows the valve to open once a pressure is reached on the side opposite of the load hold valve. This ratio is fixed for all working conditions of the machine. It is not dynamic. A couple of watchouts. Valve failure is typically open on this condition with mechanical load hold valves. Instability because of fixed ratio can be caused due to variable speeds, load geometry, system variations, and the environment. Again, the fixed ratio is a mechanical adjustment, which is typically done at the factory. Now we will review the HKX electronic load hold kit solution that counteracts these mechanical load hold valves on the market. The HKX load hold solution is electronic, and all adjustments of the valves is done via a parameter screen. Our kits fit both code 61 and 62 ports directly to the cylinder. We use sensors to measure the rod or opposite side of the electronic load hold valve, green circle in the picture to the right. When the load is going the other way, we have a free flow check that bypasses the valve, which is typical in load hold valves, shown as the red circle in the picture to the right. However, when lowering, the proportional relief valve meters flow out of the control valve unit with algorithms from the load hold valve controller. Let's get into some more of the construction of the electronic load hold valve kit. I want to point out how HKX guides a customer to the design of a kit. On the picture on the right, as we look at the depiction of the excavator on the slide, you will notice G numbered sections. We segment our machine by group numbers above. As for example, on the excavator, G1 signifies the boom system, G2 the arm system, G3 the valve system, and G4 the control system. Diagram on the left, this is a simplification of a typical load hold system that just incorporates the boom and arm cylinders. This may be construed as what is known as the ISO setup. HKX has applied this kit where both ports on bucket and arm have load hold valves as well as the bore side of the boom cylinders. The makeup of the system is a load hold controller, load hold valves, cylinder sensors, and joystick sensors. All the variation of the system is done within the load hold valve controller, which is done via a parameter screen on your laptop. So how is a electronic load hold kit delivered to you? The delivered kit is designed to follow the groups that were shown on the previous page. The kit will arrive on a pallet designed to reduce shipping costs. The kit will be housed in our engineered packaging for durability and ease of disposal. There will be an installation manual that will guide you through the install as you tackle each group number. You'll also be shown how to change the parameters of the controller to set up the system. The manual will also provide instructions on how to contact HKX if there's a problem. The installation manual is comprehensive with 4 distinct sections: before the install, installing the kit, after install, and an appendix to help you with any references and best practices. We want the acquisition of the solution to be as seamless as possible for the technician installing, and for the operator running the excavator. For the purpose of this presentation, we'll show the 6-valve system starting with G1 boom. This shows the installed electronic load-hold valves on the arm and boom cylinders. Both boom cylinders have the valve installed. It would be just a mirror image as shown above in the picture with the yellow cylinder. You'll also notice a drain line that comes from the load-hold valves. This drain line is for draining the valves where there is a little accumulation of oil within the valve body operation. This is very low pressure. All of the electronic load-hold valves have the drain, and all the drains can be terminated together for one line to the tank. The G2 or the arm group is very similar. Besides the drain line, each valve also has an electrical cable that terminates back to a compartment on the excavator where the load-hold controller resides. The cable and drain line are routed using HKX grommet connectors as shown above on the right-hand side. The other aspect of design is the ease of installation by providing new hydraulic piping and hoses to connect to the existing OEM lines. Since we do not have any valves in the OEM valve compartment, we don't have a G3 group. The next group for the install of the electronic load-hold kit is the G4 controls group. This is where we install the high pressure sensors for the opposite end of the valves to determine the pressure when trying to open the valves. The kit contains all the components to install these sensors seamlessly into the existing OEM hydraulic lines. The next step is to install the joystick sensors, which are low pressure sensors. These detect when there is joystick movement and are critical to shaping the functional curve for the load-hold valves. The final step is to install the load-hold valve controller or controllers and route all the wires to that controller. This electronic system does not interact with the OEM excavator control system. The system is completely independent and only draws information in the way of fluid pressure from the system. In systems that do not have pilot pressure, such as some CAT machines could have, we will pull an analog signal from the machine and bring that into the control to mimic a pressure sensor, so when we know there's joystick movement. After the install, then the machine can be configured. In the installation manual will be directions on how to set up an interface with the electronic load-hold valve controller. The step-by-step instructions will lead you to how to apply the right parameters so that the valves behave the way you want them. Remember, mechanical load-hold valves cannot be adjusted so seamlessly. In troubleshooting the valves, you can also bypass setting the manual override to 2000, and then the valves will remain open. The valves only stay open if power is applied to the valves. The valves remain closed when the machine power is turned off. I would caution connecting the controller to live battery. Instead, connect to auxiliary power so that when the machine is off, that the coils are not energized. Otherwise, you could drain the batteries over time. The operation of the HKX electronic load-hold system is a pressure control system in its simplest form. We control the base of the load by electronically monitoring the resistance to movement of incoming fluid. This is accomplished using this pressure sensor site opposite the load-hold valve. The electronic load-hold valve adjusts the ratio to maintain stability throughout the movement. This cannot be done with a traditional mechanical valve, which is typically fixed ratio. The electronic load-hold valve also adjusts pressure setting for optimal efficiency. Again, to reiterate, we are constantly adjusting the ratio through a curve so that you have smooth operation. The algorithm deployed adjusts both the pilot ratio and the pressure setting throughout the operation of the valve. HKX is also designed in a mode switch that opens the valves automatically when there is a joystick movement so that the machine can be used seamlessly for digging. So if one day you're operating the machine and you're holding a drill, for instance, you want obviously to have that load-hold system set up for that drill, but then the next day you want to put a bucket on it, you change to a different mode, and now you can seamlessly dig with that machine. The HKX electronic load hold kit is also compliant to ISO 8643 for hose burst protection. If there's a major leak or a burst hose, the system will automatically lock the valve based on operator commanding joystick to neutral. This would be true for all valves applied to any cylinder, bore, or rod side. Now let's look at some success stories. This is a word rock drill that weighs about 7,000 pounds, being lifted with a John Deere 350G. Word Rock uses this machine for demonstration of the rock drills they produce for their customers. They complained about drift when demoing the drill, and we offered to install a 6-valve system on the machine: boom, arm, and bucket. The left side of the video shows the load hold system off, and the right is with the load hold is on. As you can see on the left, the system drifts. The one on the right holds. Any movement shown in the video is the operator positioning the drill. We held the drill 15 inches above the ground for more than 30 minutes, and the drill never moved a 16th of an inch. This will allow Word Rock's attachment to drill more precisely, fewer or no broken bits, and less pressure on the operator to control the drill position. In the end, the climb for the drill and the machine will be more productive, better positioning of the drill, and less downtime to broken drills. This was a project we did with Tractor Equipment and Russo. This is a PC360 with a clem drill. The drill weighs about 8,500 pounds. Ironically, the PC360 was a machine sitting in the back of Russo's yard. They repaired some cylinders, and we installed our 4-valve kit on this machine. As seen in the video, there's no operator in the cab to constantly reposition the drill. Now, we don't support the idea of an operator removing themselves from an energized machine. However, as you can see, the operators are focused on the drill operation and not the position of the drill. Again, they are positioning a 8,500-pound drill with no drift. The other aspect is that they could remove the drill and install a bucket with no measurable effects to the operator productivity. This is a PC490 LCI machine with intelligent machine control. In the past, any mechanical valve would not allow the intelligent machine control logic work for grade control. The hesitation that comes with a mechanical valve building pressure to open was not suitable for this type of machine. The machine logic would see hesitancy in the system and thus would throw errors which would inhibit the use of load hold valves. On this machine, we installed a 3-valve system, which is boom and arm only. As you can see, a professional operator functioned the machine and could not even notice that load hold valves were on the machine. The intelligent machine control worked seamlessly, even though we had functional load hold valves on the machine. To recap the HKX benefits of this kit: no boom, arm, bucket drift. Hard to perform with mechanical valves. There's lots of tuning that would be required. And again, mechanical load hold valves, most of that tuning would have to be done at the factory. Improved operator feel. Operator feels that they are in control the whole time while operating the machine. In some cases, operators felt we took out the sponginess that is caused with the fluid from the cylinder back to the main control valve. Again, the mechanical load hold valve is not as easily adjustable to improve operator feel. Efficiency. Anytime we can reduce pressure drop, we hence reduce lost horsepower. In our electronic load hold system, a 4-second period at 41 GPM yielded about 175 PSI drop through the valve. In a regen lowering condition, 2-second period at 82 GPM yields 210 PSI drop. In a comparable mechanical load hold valve, the same thing. At 41 GPM, we have a 325 PSI drop. And then in regen with 82 GPM, we have a 750 PSI drop. Versatility and adaptability to changing work conditions. What's nice about the electronic load hold system, it can be electronically adjusted to any environment conditions. With the mode switching, you can switch from one mode to another. So if you want to go digging the next day, it's easy to do that with a simple flip of a switch. Mechanical control is fixed and is not as adaptable to changing conditions. So every time you need to make a change, you'll be, adjusting the valves, sending them back to the factory. Also, you got to remember on a lot of mechanical load hold systems, there's a pilot line that needs to be bled. So if there's any trapped air in that pilot line, that could also cause the mechanical load hold systems not to react appropriately. Reduce cost of ownership to end user. Now, this is a theoretical in nature, but assume 20-second operation, a continuously over 8-hour day, equates to about 2.4% fuel savings. Again, because the mechanical load hold has higher pressure drop, that equates to less fuel savings. And then ease of technology adoption. Parameter changes via controller can be done through the HKX kit instructions. Again, we make the kit easy for you to adopt. Cost of adoption is lower and cost of ownership is going to be lower for your customers. Again, the mechanical load hold system, inconceivable. I've never seen one in the market where all the cylinders, arm, bucket, and boom, have load hold systems on them. If you were, there would be a lot of tuning that would need to be done. Whereas with the HKX system, you could do that all electronically. This is the end of our webinar. There are probably a lot of details we have not discussed. I would recommend to reach out to us here at HKX. You can see the contact information off to the left. This slide shows several ways to connect with us, and we can then discuss your specific needs for your machine or project. I want to thank you for your time and attention, and we hope that you can reach out to us sometime so we can make your excavator top performing to meet your needs. And at this time, we'll answer any questions. Darren and Robert, if we have any questions.
There's nothing in the Q&A so far. If anyone has any questions, go ahead and type into the Q&A.
Or if you prefer, I can unmute you. So just raise your hand. It's really important stuff, right? You can help your clients get the most out of their equipment. That's really what it comes down to.
All right, if there's no questions.
Does not.
Okay. If there are no questions, hey, I want to thank everybody that attended our webinar today. And please, if you have any questions, use the contact information here on the screen and contact us here at HKX. And we will work towards helping you get your machine to be a top performing machine when a load hold system is needed in your market. Thank you.
Well, thank you, everyone. And we have recorded this. We'll be sending that out a little bit later today. And you can share that with coworkers or anyone who you think would benefit from this presentation and this solution. I want to thank you all again for attending and have a wonderful day.
Thank you, everyone.